A lion at full sprint is a massive expenditure of energy, but most chases end in a miss, leaving the predator exhausted and empty-handed. Hunting is a biological gamble. Apex predators operate on thin margins, where a high failure rate means wasting precious calories on a pursuit that yields nothing. This reality led to the theory of optimal foraging. Optimal foraging suggests that animals hunt the closest and easiest targets available to minimize the energy they spend searching for food. Biologists have long debated if this is a random process of opportunity or if lions are performing a more complex cognitive evaluation of their surroundings. Successful hunts follow a strict three-phase cognitive sequence. It is a system of mental checkpoints that begins hours before the first step of a sprint. Lions operate as tactical strategists. The hunt begins as a series of mental calculations, ensuring the physical strike is the final part of a much longer game. Phase 1 begins right here, in the macro landscape. This is the encounter phase, where the lion's first objective is to find a specific target within the vastness of the savanna. A study by Matt Hayward in Addo Elephant National Park tracked how lions locate their meals by measuring their encounter rate. The encounter rate is a metric that tracks how often a predator physically crosses paths with a potential prey animal within its territory. Lions deliberately position themselves in habitats favored by their preferred species. This targeted foraging means they encounter Cape buffalo far more frequently than random chance would predict. They apply the same spatial logic to potential threats. Lions actively avoid territories heavily populated by elephants, choosing their paths based on risk assessment. A lion's spatial positioning represents a mathematical strategy. They choose their location to stack the odds of a successful hunt long before a target is even in view. Phase 2 is the moment of visual contact. Simply spotting a prey animal is not enough to trigger an immediate attack. Quantitative data shows that when lions look at their preferred prey, they choose to initiate a hunt at an exponentially higher rate than their baseline average. Lions frequently cross paths with abundant prey species like ostriches or hartebeest. Yet, despite these animals being readily available, the lions ignore them, initiating hunts at a fraction of the expected rate. This selective behavior indicates a system of cognitive target selection. Lions make conscious decisions based on efficiency, committing energy only when the target meets their tactical criteria. Phase 3 shifts to the microhabitat, the level of the physical stock. This is where the lion uses the environment as a tactical tool. To map this phase, researcher Scott Laurie used LiDAR laser pulses to map the environment's three-dimensional structure. It revealed a tactical divide. The stock ends and cognitive choice is replaced by physical instinct. Here, the geometry of the ambush meets the biology of the predator. Biological data shows a surprising trend in this final phase. A lion's actual kill success rate is not statistically higher for their preferred prey once the sprint begins. This suggests that success depends on factors outside of pure speed. The final 10 seconds of a chase are often a formality. A lion secures its meal through the evaluation of terrain and the calculation of probability. These are decisions made hours before the final charge.